I've got the firing board from a Yaskawa Varispeed 626 MT2 type CIMR-NT2-15K. We're looking at the base waveforms, the base emitter waveforms right here on that oscilloscope. I'm powering up this board with plus and minus 24 volts DC, minus 24 here, plus 24 there, and ground here. And that powers up all of the voltages required by this board. I got two power supplies right here providing that plus and minus 24. The function generator here is creating a 5-volt peak square wave that's driving into the optocouplers, and the output provided by each firing channel is shown on the oscilloscope right here. I'll show you the hookups when I get back to the house so that you can power up and test your own Yaskawa firing board. Here's the firing channel that we were just looking at. This one right here. This is the base on the gray wire going to the oscilloscope, red probe, and here's the emitter on the brown wire going to the ground probe of that oscilloscope. Over here on pins 37 and 38 I've got 5 volts, and here is the square wave into this optocoupler right here from the function generator. That's on pin 49 right there. The other firing channels that run the motor are, there's 49, 47, 45, 43, 41, and 39. The function generator right here is putting out a 5-volt 1 kilohertz square wave into that optocoupler, and I have a 220 ohm resistor right here between that 5-volt square wave from the function generator and the input of that optocoupler right there. Ground of this 5 volts is going to ground of the function generator. Let's go look at the oscilloscope waveforms. Now, just the board on your bench, this is the waveform. Let's spread that out a little bit so we can see what's going on here. The peak of the base firing waveform here is at about 6 volts peak. Then it dips down to about -7, -8, comes back up to about 2.5, and then shoots back up to a peak of 6 volts right there. Every channel that you look at should look like this right here. If it does not look like this, there's a problem in that firing channel, and you have to go in there and fix it. Evening all. Here we are at the house, and we're going to talk about how to test that Yaskawa firing board. This is the rectifier and filtering for that power board. This is how that power board powers up. Now, I've never seen a transformer like this. You have AC center tapped, AC center tapped, AC center tapped, and we have 3 bridge rectifiers. So you have AC into this first bridge rectifier, AC into this second bridge rectifier, AC into this last third bridge rectifier, and all referenced through a center tap transformer. I've never seen a transformer like that. Now I've seen center tap transformers before, but they'll only have one winding, not three. So these bridge rectifiers rectify the AC to DC. We have a forward bias diode right here that makes the positive voltage for that firing board. We have a reverse bias diode down here that makes the negative for that firing board, all referenced around this ground right here. In order for me to power up this board without having to dig that transformer out of the belly of that drive, I put plus 24 volts DC on the anode of this rectifier right here from an external power supply with the ground connected to pin 7. The external power supply is ground connected to pin 7. Secondly, I put a negative 24 volts DC on the cathode of this diode right here, and it referenced to this ground right here to make a plus and a minus voltage with ground in the middle. And that powered up that firing board. Let me show you a diagram I drew where those diodes are at. Here are the 4 bus capacitors for that power supply that we saw in the last diagram. They're 4700 microfarad at 50 volts each. Here is the forward bias diode that's between the bridge rectifiers and the filtering capacitors, these bus capacitors here. And I clipped 24 volts DC onto the anode of this diode right here. And I clipped a negative 24 volts DC from a second power supply on the cathode of this diode right here. I clipped the ground between the 2 external power supplies to this pin right here on the connector that's beside these bus capacitors. In order to test the firing channels on that firing board, we have to understand the circuit. Each of the 6 firing channels that run that motor, that drive into the base of those transistor power modules, has an optocoupler. So we have 6 optocouplers. We have 6 hybrid modules. The optocoupler part number is PC614. Its anodes are common. All 6 optocouplers that are in those firing channels are common pin 1. All pin 1s are connected together on those 6 optocouplers, and they go to pin 37 and 38 of the 50 pin ribbon connector labeled 3FC on that board. So we take an external power supply and apply 5 volts DC to pin 37 or 38. They're both connected together. That applies 5 volts to the anode of that input optocoupler on input LED in that optocoupler. The cathodes of the 6 optocouplers also connect to that 50 pin ribbon connector. We have pin 2 of this optocoupler goes to pin 49 of 3FC. The other optocoupler goes to 47. The third optocoupler goes to 45, pin 45. The fourth goes to 43. The fifth to 41, and the 6th optocoupler, pin 2, connects to pin 39. The output of the optocouplers go to a hybrid module on pin 14. So you have 6 hybrid modules that drive into that firing channel circuit. We want to test this hybrid module and that firing channel. We take an external 5-volt DC, connect it to 38. We take a function generator whose square wave is set to 5 volts peak, so it swings from ground to 5 volts peak, and we connect that to 49 through a current limiting resistor. Notice on the board, this is on the board, all this is on the firing board, there's no current limiting resistor. So we have to externally use a current limiting resistor. I use one, a 220 ohm quarter watt resistor. So when the square wave is at ground, the cathode is connected to ground. The anode is at 5 volts from the external 5 volt power supply, and current flows through the LED inside that optocoupler and turns on the phototransistor, which puts plus V through the phototransistor collector emitter to pin 14, and pin 14 goes high. When pin 49 is at 5 volts, we swung from ground to 5 volts. We have 5 volts up here on the anode from the external power supply, and we have 5 volts on the cathode from the function generator, and no current flows because we have 5 volts up here and 5 volts down here. So that's off. We test the other optocoupler hybrid module firing channels in the same manner. We just move the function generator from 49 to 47, then from 47 to 45, then from 45 to 43, then from 43 to 41, and then from 41 to 39 until we've gone through all 6 firing channels. We only test one at a time. Alright, let me put up the output of the hybrid module, and we'll see how that works. Now here's the hybrid module right here, and it drives into 2 NPN transistors. Up here, the collector of this NPN transistor is at plus voltage. The emitter of this NPN transistor is at a negative voltage. Between the two, we drive into the base of this power transistor right here. And we are looking, I'm about to lose my paper, it's going to fall on the floor. Don't do that, we're not done yet. The output of the power transistor is what we're looking at over here. Here's connector 7MCN. That's the 4-pin connector. And we're looking at the base and emitter when we're applying that square wave to the input of the optocoupler in this firing channel. These connections right here are where the collector, base, and emitter for that power transistor are connected to the firing board. Now these voltages, all of these voltages, these plus and minus voltages, they're isolated from the other firing channels. Each firing channel has a supply generating this plus V and minus V. Now here's the test. After all that, we finally made it here. Here's the 50-pin ribbon cable connector right here. There's pin 38, and remember, we apply 5 volts DC from a power supply, an external power supply, to pin 38 or 37. 38 was the easiest to clip on. Here's the function generator, 1 kilohertz square wave, plus 5 volt peak to ground. the output of that function generator through a 220 ohm resistor connects to the optocoupler 49 or 47 or 45 or 43 or 41 or 39, depending on which output we want to look at, the fire channel. In our instance right here, we're looking at the connector of 7 MCN. We have the oscilloscope. We used a fluke oscilloscope connected to base with the red probe and emitter with the black probe. When we move from 49 to 47, we have to move that oscilloscope to the next connector, which is 8 MCN. It'd be connected exactly like this, but it'd be 8 MCN. And so forth down the row there. The ground of the power supply, the 5 volt DC power supply, is connected to the ground of the function generator. Now I'll put all this documentation up at the end of the video, and y'all can recreate it. And you can test your Yaskawa firing board. All right, folks. Thank you very much for stopping by. And that sun's going down pretty quick. We got to get up and go back to work. I ain't even cooked dinner yet. All right. We'll see you next time.